Okay, let's go through a quick run through about what are buffers, what are they used for. We won't get into the math of buffers, which is kind of nice. They're kind of tricky. But we at least need to understand what a buffer is, what its purpose in the world is. And a buffer is defined as being a solution made from a weak acid with its conjugate base. It has both components in it. Another way to, a different kind of buffer, also a buffer, would be a weak base with its conjugate acid. So I have a base acid pair, and I'm talking about weak acids and bases. The purpose of it is to help control pH so that it doesn't change very much if I add strong acid or strong base. This is really important in a lot of biological systems. The pH can't swing by very much. If my pH in my body goes to pH 2, it's going to probably be fatal. It's certainly going to wreak havoc on my system. So my body's pH can only range from, I'm not sure the values, but on average it's in the 5s, and it really should be somewhere between 5 and 7. So my purpose is I have some ingredients that can react with strong acids and that can react with strong bases. My weak acid is capable of reacting with strong base to eat it up so that the pH doesn't change by very much. The conjugate base can react with the added strong acid to eat it up so that the pH doesn't change very much. If I didn't have the system buffered and I were to add strong acid, the pH would drop drastically. If I didn't have a system buffered and I were to add strong base, the pH would go up drastically. So the buffering helps control. It will still go up or down, but not by very much. What's going on here, if I look at a system, CH3COOH is acetic acid, it's a weak acid. CH3COO- is its conjugate base. We could also call this acetate ion. I could make a buffer by using something like sodium acetate or potassium acetate, something that when I dissolve would provide the acetate ion in solution. If I add strong acids can react with bases. CH3COO- is a base. It's the conjugate base of this weak acid. So this base can now act with any added, so suppose I add hydrochloric acid, strong acid, this can react with it to sort of diminish the effect of the HCl so that the pH will change, but not by very much. If I use this, you say, oh, but what if you use it up? You don't have very much, it's a weak base. Yes, but remember, when I start to decrease, what happens in this equilibrium system? Some of my weak acid will get converted to its conjugate base, because when I remove a concentration of a product, the equilibrium will shift towards products, it will make more of this, and I have more to react with the added HCl. So this will continue producing this until it's sort of eaten up the added HCl. What if I were to add sodium hydroxide, a strong base? Well, strong bases can react with acids, and I happen to have a weak acid here. So this is acetic acid, this is my weak acid. If I add sodium hydroxide, it produces hydroxide ions, which can react with this weak acid. Again, you say, yes, but it's a weak acid, maybe I don't have too much of this present. What happens when I react this away? Well, this is the system in equilibrium. And when I remove this ingredient, the reactant, the reaction will shift towards the reaction side. It will produce more of it that's able to react with NaOH, so it decreases, so it produces more of it. So the buffering system has the capacity to deal with added acids or added bases by having both of these ingredients that are in an equilibrium system that can adjust to changes in concentration. Again, if I add base, it reacts with the weak acid. If I add acid, it reacts with the weak base. I have both components of the system. Now, I've shown you a weak acid buffered system where I have a weak acid with its conjugate base. I could have redefined it as a weak base buffer where I have a weak base along with its conjugate acid. They're really the same thing. And that's the concept of buffers, very important in biological systems within cells for homeostasis, to keeping the pH levels under a controlled pH within the human body. Also very important in drug design. If I give an important drug, but that drug is acidic or basic, I need to have that system buffered so that along with it I provide some buffering so that it doesn't change the pH of the system that I'm trying to put the drug into to do good.